Hello and good morning. Let's take a look at this work here. Okay, so number one says this guy's principle to explain why the volume of the two stacks are the same. Well, the bottom is a circle, and so is the bottom here. So if the dimensions are the same and the height is the same, then the volumes should be the same. All right, number two, under what conditions are the volumes of two solids equal? When the area of the base are equal and the height. When the base area is the same as the base area and the height, then that is his principle. Let's take a look at this one right here. There are three choices here, and we're going to mark them and then work them. Okay, so let's take the first one. This one right here, if you take a circle and they divided it into 1, 2, 3, 4, 5, 6, 7, 8 pieces. So that would be 4, and that should be 8. Okay? And so 360 divided by 8 is going to give you 45 degrees. So each one of these is 45 degrees for a total of 360. So let's think about this. If you look here, it says the area of the parallelogram. The parallelogram is going to be this, base times height. Okay? So if we look, this part right here is really half of the circumference. So this is half of the circumference. Okay? So if you take the base, which is half of the circumference times the height, and the height here is actually the radius of the circle. And so here it is. It's half times the circumference times the radius. And that one does work. The radius of the circle is approximately equal to the height of the parallelogram. That's true. The height of the parallelogram, which is this, is approximately equal to the radius. It's got a little bit of a curve here, but that's why they say approximately. Okay, so if you do the area of the sector, you have 45 degrees right here out of 360 times pi times radius squared. But you have 8 of these. And there it is right there. Okay, let's go to the back side. All right, I'm not sure what they want us to do. Select two objects with the same volume. So you got to figure out the volume of all of these. And let's just do that. So this one right here, the area of the base is pi radius squared times the height. Okay? But the radius is not 3, the radius is 1.5. So you're going to have 1.5 times 1.5 times 4 times pi. And so you're going to get 9 pi on that one. This one right here, the area of the base is pi radius squared times the height. But then you have to divide by 3 because it comes to a point. So let's figure this out. So pi is 3.14. The radius is 4 times 4 times 2, and then divide by 3. This one, if you leave it as pi, let's scratch that out and leave it as pi, you're going to get 32 over 3 pi. This one is 4/3 pi radius cubed. Memorize that. So it's 4 times pi times 3 of the radiuses. The radius is 2. Half of that 4 So that gives you 32 over 3 pi. And so this one would match up with this one. And no need to even do that one. Okay, the next one, you have a sphere, but the radius is 2. You have a cylinder right here. And you don't even have a full sphere, so it's 4/3 pi radius cubed, but you have to divide by 2 as well. The cylinder is pi radius squared times the height, and you got to add these up. And the cone is pi radius squared times the height divided by 3. And so if you do all of that correctly, you should get 205. So I'm going to let you work that one on your own. And there it is. Just keep in mind that the radius here is 2. This one is half of a whole sphere. And then finally, the last one, calculate the volume of the sphere, right here. Calculate the volume of the sphere. Okay, here they're giving you some density or whatever. We did not do density. We're going to skip this one. Okay, but again, on the test, try it anyway. Look it up on YouTube for density. See if you can figure this one out. That's it for today. Have a good morning.